Look at any modern enterprise at scale, and you see a chaotic web of interconnected systems. Thousands of data nodes, legacy databases, and live applications pulse simultaneously across the network. Compare that to the clean, empty text box of a consumer chatbot. Asking a single model to write a poem is trivial, but integrating autonomous AI into corporate chaos is an entirely different engineering discipline. That exact challenge is what the Microsoft AB100 certification tests. The Agentic AI Business Solutions Architect exam is designed specifically for IT professionals and system administrators stepping up into high-level enterprise design. The AB100 forces you to abandon the fantasy of a single omnipotent AI. Deploying a standalone model is simple. Orchestrating a secure web of AI agents that safely interact with Dynamics 365 is incredibly difficult. You cannot rely on ad hoc API scripts. Agents require strict blueprints, compliance firewalls, and precise cost ledgers. To pass this exam, you must stop thinking like a developer testing prompts and start thinking like a risk-averse enterprise architect. To see how this works, we are going to reverse engineer actual AB100 case study questions. First, quantifying return on AI investment. Second, standardizing extensibility through open frameworks. And third, enforcing immutable prompt governance. Success on the AB100 depends on moving beyond feature memorization to adopt a defensive, risk-centered architecture. Under the AB100 framework, an agentic AI deployment is evaluated as a financial asset first and a technical capability second. Technical teams naturally want to validate a new model by measuring its token speed, accuracy, or reasoning capability right out of the gate. But look at this exact exam question. It presents a scenario requiring a return on AI investment analysis and asks, what should you do first? Option A suggests establishing AI performance metrics. Selecting performance indicators prematurely guarantees misaligned metrics. Performance has zero meaning until you know the financial context in which it operates. Option B suggests conducting an AI market benchmarking study. Market benchmarks are useless if you lack an organization-specific baseline of your own capital expenditure. You risk making irrelevant external comparisons. The correct architectural standard is option D. You must identify and explicitly quantify all development, deployment, and operating costs before doing anything else. In a Microsoft ecosystem, that means calculating Azure Compute integration, ongoing Copilot licensing, routine maintenance, and internal user training. Without this quantified cost baseline serving as your denominator, any projected efficiency gains or ROI calculations are mathematically unverified speculation. Once an enterprise establishes these financial baselines, it inevitably ends up with a portfolio of different AI initiatives at various stages of maturity. The Microsoft-approved method for managing this portfolio is a horizon-based framework. This plots projects across axes of short-term efficiency and long-term strategic value. This structure forces you to weigh immediate financial returns against risk exposure and capability development. As models mature, early-stage experiments drop off, and high-impact long-term investments scale up. Technical brilliance cannot save a system if its financial anchoring is flawed. Cost modeling is the absolute prerequisite for all subsequent engineering. This strict architectural discipline extends directly into how we connect systems together. Consider the exam's Fabricam Inc. case study, where a global consumer goods company is migrating its entire infrastructure to the Microsoft Cloud. Fabricam's core requirement is to implement AI to streamline B2B sales cycles and automate prospect correspondence. To build this, architects must use Microsoft Copilot Studio as the mandated central hub for creating these custom agents.
But a central agent is useless in isolation. The immediate challenge is securely connecting this hub to dozens of siloed data sources without breaking the network. Writing custom point-to-point APIs for every single integration creates a brittle, unscalable mess. It is a practice that will fail the exam standard. The correct architectural solution is the Model Context Protocol, or MCP. MCP acts as an open standard translation layer. It allows AI models to securely invoke external tools and read contextual data from those silos without requiring hard-coded custom integrations. This guarantees interoperability across the entire suite of Microsoft 365 and Dynamics 365 applications. And when multiple specialized agents need to collaborate, you deploy the agent-to-agent or A-to-A framework. A2A enables a customer-facing sales agent to securely query an internal supply chain agent to verify inventory, entirely without exposing the underlying raw data tables to the front end. The Sabricam case study also tests how you handle unexpected AI behaviors. The system requires a strict human-in-the-loop escalation path. If an agent fails to answer a question twice, it must automatically reroute to a human representative. Your orchestration layers must be explicitly designed to trigger these manual handoffs gracefully. You can never trap a user in an automated loop. Designing agent extensibility means building a highly standardized, fail-safe nervous system that protects the enterprise at every connection point. That brings us to the final and most defensive requirement of the AB100 exam, securing the multi-agent system from manipulation. The primary cybersecurity threat is prompt manipulation, where unauthorized users feed aggressive instructions into an agent to bypass guardrails or force a data leak. This practice question asks how to design a shared prompt library across multiple business units. The solution must ensure consistent responses, support governance, and minimize administrative effort. You cannot treat prompt engineering as a casual end-user activity where employees tweak instructions on the fly. Under the Microsoft standard, prompts must be treated as production code. The correct approach is to define standardized prompt templates, removing variability and locking down the model's instructions. To enforce this, these templates must be stored in a secure Git repository. A Git repository actively solves the governance requirement by enforcing strict version control. If an unauthorized user attempts to merge a change into the main branch, the system blocks them. Access constraints dictate that only designated AI engineering teams hold the permissions required to fine-tune models or push prompt updates. This creates an immutable audit trail. When a risk officer needs to see exactly who changed a prompt and when, the data is entirely transparent. In a corporate cloud environment, unmanaged prompts are a critical vulnerability. Real governance requires zero-trust prompt management. When we zoom out, we see the complete mental model of the Fabricam Agentic AI architecture. The financial ledgers form the base, the Copilot Studio orchestration layer sits in the middle, and the Git-governed prompt vaults secure the top. The AB100 measures the ability to transform raw AI capability into a secure, auditable corporate asset. Every deployment must be grounded in an ironclad, cost-quantified baseline. Your systems must scale cleanly using standardized translation protocols like MCP, and your execution layer must be locked down with Git-backed governance to prevent manipulation. Architectural mastery and passing the AB100 exam happens when your technological ambition is perfectly constrained by financial reality and strict enterprise risk management.